Here's a good one for you that a lot of teachers like putting on a test just to try to trick you. The question is what's the derivative of 9e? A lot of people would think that it's e to the 1, so they'd try copying and pasting and say it's 9e times, what? I don't know. A lot of people would think the answer is 9e. But what you have to remember here is that 9e is technically just a constant. And remind yourself that the derivative of any constant is 0. So a lot of students would get that wrong on the test because they just overthink it. They're thinking copy and paste. Well, that only works when it's an exponential function. Function meaning that you have to have x in the exponent. Here we don't even have x. We are just dealing with a constant. Remember, e is a number. This is a constant. The derivative of a constant is 0. Again, we're going to continue on. How about e to the 3x plus 1? We're going to find the derivative, just do that copy and paste. So it would be e to the 3x plus 1. For exponential functions, you do the copy paste, right? And then you need to multiply times the derivative of the exponent. So that would be the derivative of 3x plus 1. Well, what is the derivative of 3x plus 1? Derivative of 3x is just 3. Derivative of 1 is 0, so the derivative is just 3. Clean it up just a little bit. What would we have? We would have 3 times e to the 3x plus 1. And we're done. Let's move on. Beautiful, beautiful, beautiful test problem here. Again, when we first started the product rule, which was just a couple sections ago, when we first started the product rule, you could have foiled out the problems and not had to use the product rule at all. So it was kind of worthless in a sense that it wasn't necessary. Well, here it is absolutely 100% necessary that you use the product rule to find this derivative because you have x squared times e to the x. So what you got to realize here is to find that derivative, again, we're going to be 1d2 plus 2d1. The first times the derivative of the second plus the second times the derivative of the first. The first function here would be x squared, and the second function here would be e to the x. What's the derivative of x squared? That's simply 2x. And what's the derivative of e to the x? Well, that's e to the x. And remember, you do 1d2 plus 2d1. So my first is x squared. The derivative of the first is e to the x. Plus the second function, which is e to the x, times the derivative of the first, which is 2x. So really what I'm looking at is x squared e to the x plus 2x e to the x. Usually I'd be perfectly fine with you guys putting that as your final answer. However, when we have exponential functions, they're always going to have an e to the x in common when we do something like the product rule like this. So I ask that you actually do factor this out. So I want you to see, what do both of these terms have in common? Well, certainly they have an e to the x in common, but and if you look even further, they actually have an x in common, don't they? So let's think about that. What's x squared e to the x divided by x e to the x? Well, x squared divided by x is x, and e to the x divided by x is just 1, so we would just have an x. 2x e to the x, if we divide that by x e to the x, the x's would cancel, the e to the x's would cancel, we'd be left with just 2. So the answer to the problem would be x e to the x times the quantity x plus 2. I do want you to put it in factored form there. I do not want it in the expanded form. Anytime you have an exponential function, I want you to factor it. Okay, let's look at this next one. F of x equals e to the x plus e to the negative x all over 2. I could see a couple of different ways of doing this problem. I could see some of you wanting to jump onto the quotient rule train here. I wouldn't use the quotient rule. The reason that I wouldn't use the quotient rule is because it's just a constant on bottom, and it's actually just a 1/2 really is a constant multiple. So personally, I would do the constant multiple rule and just pull it out. Okay. I could also see some of you dealing with the e to the negative x. I mean, what you could be thinking about here is this is e to the x plus 1 over e to the x all over 2. And you could sit here and say, wait a second, this is a compound fraction, and if this is a compound fraction, I need to get a common denominator. So to do that, what would we have to do? Well, we'd have to multiply every single term times e to the x. So I could multiply this times e to the x, this times e to the x, this times e to the x. If I did that, I would have, the first term would be e to the x times e to the x. Well, that's e to the x quantity squared, But remember, when you raise a power to a power, you multiply them. So e to the x quantity squared is really just e to the 2x. Okay? And then notice what would happen on the next terms. The e to the x's would simplify. I'd just be left with 1. And on bottom, I'd have 2e to the x. So this is one way that I could look at this problem. And I could handle this by either separating and finding the derivative of two individual terms, or now I could use the quotient rule. It doesn't really matter. So I can see numerous different ways of finding the derivative of this function. Okay? I don't know what your strategy is. Usually when I ask my students about this, the gut reaction is, hey, let me use the quotient rule. And then I say, really? Do you have to use the quotient rule? And the answer is no, they probably wouldn't use the quotient rule because they realize it is just a 2. So I'm going to do it the majority of the way that my students would do it in the class. The majority of the way my students would do it in the class is not by getting a common denominator. Most people wouldn't see that as negative exponent as throwing in the denominator and getting a common denominator. So let me do it how the majority of students in my class usually do it. What they realize is this is the same thing. I'm just going to call it y. It's f of x, but I'm just going to call it y. They'd realize that this is the same thing as 1/2 e to the x plus 1/2 e to the negative x. That's what they would realize. They'd realize that you would just separate it, both of them, e to the x over 2 and e to the negative e to the negative x over 2, and then write that as a leading coefficient. And that makes it pretty dang easy to find the derivative, because when I do that and I want to find the derivative, what's the derivative of 1/2 e to the x? Well, copy and paste 1/2 e to the x. What's the derivative of 1/2 e to the negative x? Well, again, copy and paste 1/2 e to the negative x, but it's not just x, so I need to find the derivative of negative x here. And the derivative of negative x here is quite simply -1, right? Because the derivative of x is 1. So cleaning this up, I'd have y prime, oops, sorry, let me get my right color here. I'd have y prime equals 1/2 e to the x plus, or sorry, it wouldn't be plus anymore because we multiplied it times -1. It would be minus 1/2 e to the negative x. But quite honestly, I'd accept that answer right there. I'm not mad about it. I'm not going to do anything different about it. That's good to me. Could we do more? Well, certainly. Certainly we could do more if we wanted. So for instance, I see that there is a 1/2 that I could factor out. Then I'd have e to the x minus e to the negative x. And if you want to think about that, isn't that really 1/2 times e to the x minus 1 over e to the x? Because you have your negative exponent. So I could get my common denominator like I explained doing earlier. So this would be e to the x over e to the x. This would give me 1/2. Well, again, it would be e to the x on bottom minus 1 over e to the x. It would be e to the x times e to the x, which is e to the x squared. E to the x squared would be e to the x, and then that's squared. So remember, you multiply. When you raise a power to a power, you multiply. So that's really e to the 2x, right? Now I could combine it, and I could say it's 1/2 times e to the 2x minus 1 all over e to the x. So that'd be another version of it. Would I care about this? No. No, I don't care about this at all. I mean, I could even write it a different way. I could write this as e to the 2x minus 1 all over 2e to the x. So this is most likely what they would show me in WebAssign or in my computer-assisted homework. Do I care about that? No, I don't. I don't care about that at all. I would have accepted the first one. You would have been perfectly fine. I wouldn't have made you combine this into two terms. I don't care about negative exponents when it's exponential functions. So either of those answers would have worked for me. Okay, let's move on to part E here. It says find the derivative of f of x equals e to the x over x squared. Again, excellent test problem here. I can't emphasize that enough. Why is this an excellent test problem? Because it forces the quotient rule. You have to use the quotient rule. I guess technically you could write x squared as x to the -2 and then use the product rule, but hey, you're at least using the product rule or the quotient rule on this problem, so it's a good problem to put on the test. So what am I going to do? I'm going to use the quotient rule on this, so I'm going to say the derivative is low times the derivative of the high minus the high times the derivative of the low over what's below squared. Remember here, the low function is x squared, so the derivative of the low function would simply be 2x. The high function here is e to the x, so the derivative of the high function would be, well, the derivative of e to the x is e to the x. And you always do low d high minus high d low over what's below squared. So in this case, it would be x squared times the derivative, that's the low, times the derivative of the high, which is e to the x, minus the high, which is e to the x, times the derivative of low, which is 2x, all over the low function squared, so that's x squared quantity squared. Let's clean that up a little bit. So it'd be x squared e to the x, e to the x, minus 2x e to the x, all over, well, x squared squared, when you raise a power to a power, you multiply them, so that'd be x to the fourth. We do have to simplify here, we do have to be careful, so I want you to look in that numerator between x squared e to the x and 2x e to the x. What do you have in common? Well, they both have an x and they both have an e to the x in common, so let's factor those out. So what's x squared e to the x divided by x e to the x? If we pulled out an x and we pulled out an e to the x, what's left? Simply just an x is. What's 2x e to the x divided by x e to the x? Well, the x would be gone, the e to the x would be gone, so we would just have the minus 2 left over. All of this is over x to the fourth. It's important that you do this because look what happens now. One of our x's simplify, so that would be a 1, and this would be an x cubed on the bottom. So what do I end up with on this problem? I have a e to the x on top, an x minus 2 on top, in parentheses, and an x cubed on bottom. That'd be my final answer. Let's go on and look at the next one. How about f here? Great problem here. X squared times e to the x minus e to the x. I could see multiple ways of doing this problem. I don't know how you do it. I mean, for instance, I see that you could factor out an e to the x. So this would be x squared minus 1 e to the x. So there's my function right there. So if I want to find the derivative of that, f prime of x, I'd be using the product rule. So it'd be 1d2 plus 2d1. First times the derivative of the second plus the second times the derivative of the first. So what's our first function? Well, our first function is e to the x. The second function is x squared minus 1. So let's think about what's the derivative of x squared minus 1. So again, here's my first function, here's my second function. So my second function is x squared minus 1. The derivative of that is 2x. Plus the second function, which is x squared minus 1, times the derivative of the first function. Well, what's the derivative of e to the x? It's simply e to the x. So what do I have here? Well, I'd have 2x e to the x plus x squared e to the x minus e to the x, if you will. And all I did there was just distributed out that e to the x squared and the minus 1. That's all I did. And again, I told you, you're always, if you're using the product rule, you're going to have that e to the x in common. So always see if you have anything else in common as well, but I do want you to factor out that e to the x. If I factored out that e to the x, the first term would have a 2x left over. The second term would have a x squared left over. The last term would have a minus 1, which is close to the end, but I need to write it in descending order. So I'd have e to the x times x squared plus 2x minus 1 is my final answer. So again, not the only way to do that problem. You could have used the product rule for the first part and then subtracted off the derivative of e to the x. You would have gotten the same thing. I factored it first and then used the product rule to find the derivative. I did it differently. If you look at the solutions, I did it a little bit differently. So either way works.